Most cultivars used by seaweed farmers have been vegetatively propagated since the 1970s. Vegetative propagation from cuttings provides benefits by ensuring genetic consistency and consistency in quality. However, clonal propagation is also detrimental to fitness, making the entire cultivar more susceptible to disease due to lack of genetic variation. Consequently, after decades of successful farming, farm cultivars are now observed to have lower productivity, thinner branches, and more susceptibility to epiphytism and eye-size disease, thereby compromising carrageenan yield and quality, as well as the livelihood of thousands of small-scale farmers getting their main source of income from seaweed cultivation. In this regard, there is an urgent need to generate and select new seed stocks from wild eucheumatoids found around the Philippine archipelago. The main objective of this research, entitled Selection and Curation of Safe and Healthy Eucheumatoid Seedlings for the Future, is to restore eucheumatoid productivity and production in the Philippines through the selection of new local strains that are safe and healthy, to limit environmental impacts due to the introduction of non-indigenous genotypes, and to prevent risks to disease outbreaks and crop failure due to climate change. Under this project, we will be performing the following activities: the inventory and DNA barcoding of new and old strains, and the culture maintenance of seed stocks at the Seaweed Culture Laboratory and Gene Bank, and at the Bolinao Marine Laboratory outdoor land-based nursery. We will also conduct a series of ecophysiological studies, biochemical analysis in collaboration with BFAR National Seaweeds Technology Development Center, sea-based cultivation of candidate strains in Bohol and Iloilo, ependophyte and disease assessment, in vitro and ex situ reproduction, and lastly, to come up with a handbook for seaweed culture. The key deliverables and anticipated outputs of the project are refined methodology and protocol for producing new seed stock, generated and identified new and superior indigenous cultivars for biobanking, distribution, and large-scale cultivation by seaweed farmers, characterized carrageenan yield and quality of the highest performing new cultivars, identified risks to epidemic and disease outbreaks and provide mitigation measures, genetically characterized culture collections and catalog new, robust, and high-performing cultivars, and biobank disease-free strains to preserve genetic diversity with defined phenotypic traits, and finally, evaluated the performance of promising new strains in sea-based trials associated with community-run nurseries and preparing for distribution to seaweed farmers through Coast Foreseas networks.